to begin recovering debris shortly after breakup. Well, the clock is ticking down rapidly. We're just over T-minus 2 minutes and 14 seconds from liftoff. You've seen the crew access arm is back. That was retracted away from Dragon in T-minus 42 minutes. A few minutes after that, Dragon launch escape system was armed just before we began loading propellant onto the Falcon 9. So if an unplanned situation arose right now, Dragon would perform an escape. Now currently the engines are chilled in for launch on the Falcon. The Dragon spacecraft is waiting for liftoff. We have retracted. You can see in the videos the strong back is moved away just about 2 degrees in rapid readiness for liftoff. We have also finished loading liquid oxygen onto both the stages, so the Falcon 9 is just about ready. The large white cloud you see coming off of the side, we're venting down the pressure from the liquid oxygen supply line to the strong back in preparation for launch. Last event you're going to hear, start up at 1 minute when the computers take over and the launch director go at 30 seconds.
And we're coming right up on that in about 15 seconds now. We'll be just a minute from liftoff. And Falcon 9 is, as you just heard, moving into those final stages of the final countdown for the in-flight abort test today. So far, weather's looking okay. We're hoping it's going to continue to cooperate, and the range is green for launch. Now, if for some reason we scrub today, we will shift to our backup launch window, which is tomorrow at the same time. Again, this is just a test. We're fully expecting Falcon 9 to break up, so don't be alarmed if you see that happening live. And with that, let's listen in now. We're just 45 seconds from the final countdown.
Go for launch.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff, simplify and high. We're getting ready now. 3, 2, 1, 0. Ignition, liftoff, simplify and high. Ignition, liftoff, simplify and high.
Dragon launch escape initiated.
Dragon's away.
And you can hear some really loud cheering in the room.
That's why they did it.
Okay, you just saw a bright flash there. It looks like maybe Falcon 9 breaking up. We've got some loud cheers here in Hawthorne. The folks that just watched live the Dragon separate. The next milestone we have coming up at 2 minutes, 25 seconds, we're expecting to see the trunk jettison. So that claw that connects the trunk to the capsule is going to separate, allowing the Dragon to separate from the trunk. Coming up in 15 seconds.
And we do have the report. Loss of telemetry from Falcon 9.
You're going to see the parachutes when they come down.
On the right-hand side from the aircraft, it's orbiting the area. Now the Dragon control system is now going to be reorienting the capsule. We're at a high altitude where the aerodynamics are negligible. We're going to use the small Draco thrusters on the Dragon capsule to reorient it. That gets it in a position to heat shield down to re-enter the Earth's atmosphere, and then later to deploy the drone parachute.
Now those drogue chutes, we expect to get confirmation that those have
deploy them about 2 kilometers above sea level, 6,500 feet above the Atlantic Ocean. We're getting good views from the Dragon and the airplane, showing the 2 drogue chutes. Now we're just waiting for the main parachute to be deployed very shortly.
Did you catch up to the booster? Look at that big puff.
And we have the view from a different camera on Dragon showing the 4 main parachutes. Now they are deployed in a reefed condition. That means we're keeping them fairly shut to avoid shocks, and now we're slowly opening up.
That's a big
the 4
explosion out there.
Great views coming off of the Dragon camera on the left, and we can also see the 4 parachutes from the airplane on the right.
That is a really cool view.
Nice view of the orange and white parachutes as they're opening up into the second position, and then going to fully open. From fully open, we'll be descending about 20 to 25 feet per second down to the Atlantic. So from that 6,500 foot altitude, it's going to take us a few minutes to splash down. Also right now that the mains are out, a sequence is performed on the Dragon, which will reorient the crew seat into a splashdown position, give it a little better angle to take the slow bounce as we hit the ocean.
Good afternoon. My name is Bettina Klein. I'm with NASA Communications, and welcome to this post-launch press conference talking about the in-flight abort of SpaceX's Crew Dragon, an important part of NASA's Commercial Crew Program. Today with us, we have some great guests who will provide some remarks. First will be Jim Bridenstine, NASA Administrator, Elon Musk, Chief Engineer at SpaceX, Kathy Leaders, the Program Manager of our Commercial Crew Program at NASA, and astronauts Mike Hopkins and Victor Glover. They'll begin with, as I mentioned, opening remarks, and then we'll open it to questions from both the members, the media in the audience, and those who have called via the phone, and also social media. You can ask your questions on social media by using the hashtag AskNASA. With that, let's kick it off with Administrator Jim Bridenstine.
Well, thank you, Bettina. Another amazing milestone is complete for our very soon-to-be project, which is launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles. We're very grateful. Congratulations to SpaceX and the entire NASA team on this final major flight milestone that we needed to accomplish. Make no mistake, there's a lot left to do. We have a number of parachute tests upcoming, and of course we're going to get a lot of data from this particular test, and so we're not quite there yet, but by all accounts this was a very successful test. And when we think about what we have done so far with the Crew Dragon, we've had a pad abort test that was successful. We've had now a high altitude abort test that has been successful. On Demo 1, we launched, we controlled the spacecraft, we docked to the International Space Station, we undocked, and then we had entry, descent, and landing. So this is a program that is moving forward very fast, and I personally want to give my strongest congratulations to the NASA team, which has been amazing, and of course the SpaceX team, which has also been amazing. So congratulations to everybody involved, and I'll turn it over to Elon.
All right. Well, let's see. I'd like to likewise just express great appreciation and admiration for the SpaceX and NASA teams that made this happen. Without a lot of dedicated people at SpaceX and NASA, this would not have happened. So it's just thank you for your hard work and dedication to achieving this the success of this mission. There's I think a few points that are kind of exciting to note. That the peak velocity of Dragon during abort was more than double the speed of sound. It went to Mach 2.2 and achieved an altitude of 40 kilometers or 131,000 feet. So I think these are pretty exciting specs. To be for the sport to have gone more than 3 times the altitude of a typical airliner, and to accelerate that rapidly away from a booster. And I think if you saw in the video, the booster actually exploded as expected. So that was very exciting, and it landed in relatively high winds at the ocean level, which I think helps us envelope the mission for when it is crewed, since we expect this to be sort of an enveloping condition for the winds at sea level at the recovery site for when crews are launched. So overall, as far as we can tell thus far, it is a picture-perfect mission. It went as well as one could possibly expect, and again, dedication. This is a reflection of the dedication of the hard work of the SpaceX NASA teams to achieve this goal. Obviously, I'm super fired up. This is great. It's really great, and we're looking forward to the next step, and I think we'll talk more about next steps in as we get further into comments.
And I'm super fired up too. This is really exciting. As we talked about when we all got together, gosh, was it a couple of days ago? We said this was going to be an exciting test. My boss told me, hey, don't talk about launch vehicle launches and exciting at the same time, but I think you guys saw today that it was a very exciting test. I'm also super proud of the team. I really appreciate the comments from Jim and Elon. Not only was it a NASA SpaceX team, it was a multi-agency, the FAA, the Air Force, the DET, everybody's out there, made sure that we had imagery assets and the ability to be able to accomplish this mission. And honestly, folks are out there right now recovering the spacecraft, which is going to be very, very critical for us. We're super excited that it all went well. We talked about needing to thread the needle with all the weather, and we did. We did have to thread the needle. In fact, the needle was getting, the head, the eye was getting smaller and smaller and smaller, and all this will be good data for us and for our crews that will be flying soon. So thank you, Elon, to your team. Fabulous job. Thank you to the NASA team. Fabulous job, and looking forward to the next steps.
Okay, I guess it's my turn. Wow, what a day. I also want to say it's very exciting to see this, and it's great to get to this major test milestone. We appreciate certainly all of the hard work that the NASA and the SpaceX teams and everybody else that made this event happen. As crew members, our families, you can imagine, we're very interested in these escape systems and how well they work. And so we're going to be following very closely as the data comes in and we continue to analyze it and see what that means. And in fact, the work is ongoing, as was mentioned, the recovery operations. Bob and Doug, the DM2 crew, are actually taking this opportunity to follow those operations and see what they can learn from that, because this is one of the first time, or one of the only times they'll have an opportunity to see those operations when it's not them. So again, congratulations, and we look forward to the next steps as well.
And since my comments are the only thing between us and your questions, I'll keep it brief. First, to our families that are out there watching, a lot of them were very interested in this test for obvious reasons, and so far what we've seen is what we expected. So that's the first one. And then to you all, the team that has helped make this happen, SpaceX, NASA, the Air Force, and all of the folks who worked so hard to get us to this point, from the crew, but also from our families, we want to say thank you.
Well, thank you, everyone. We're going to now take questions from the media. We'll take a few questions here, and then we'll go to those that have called in social media. With that, we'll first start with Marcia.
Marcia Dunn, Associated Press. Elon, Kathy told us the other day that you could carry crew as soon as March. Is that feasible, and when do you think the crew launch might be?
Well, we were just talking about this in the green room, and my guess is the first question that will be asked is. So we agreed on a response. So it's collectively. This is not. So the hardware necessary for the first crewed launch, we believe, will be ready by the end of February. However, there's still a lot of work once the hardware is ready to just cross-check everything, triple check, quadruple check, go over everything again until every stone has been turned over 3 or 4 times. And there's also the schedule for getting to space station. So because space station has a lot of things going to it. So what's the right timing for this? And the sort of collective wisdom at this point is that we think we're highly confident the hardware will be ready in Q1, most likely end of February, but no later than March, and that we think it appears probable that the first crewed launch would occur in the second quarter.
Oh, I think that's a very fair assessment. I would also say we have to make some decisions on our end from a NASA perspective. Do we want that first crew to be a short duration, or do we want it to be a longer duration? If it's going to be a longer duration, then we have to have some additional training for our astronauts to actually be prepared to do things on the International Space Station that we weren't planning to have that initial test crew necessarily do. So we've got to look at that and make a determination. Do we want that first crew to be longer duration, or do we want them to be a quick turnaround? And those are decisions that we're going to be making in the coming weeks. But as Elon said, there's a lot of we have to understand all of the data. This was a test. It looked beautiful. We all loved watching it. But now the work begins for evaluating everything that we're going to learn on this test.
To be clear, the data or telemetry all looks picture perfect, at least as far as we've seen thus far. But we need to physically recover the spacecraft and confirm that there's not something that not an issue that perhaps didn't show up on telemetry. Yeah.
Next question. Chris Davenport.
Hi, Chris Davenport from the Washington Post. I guess for Elon and Jim, and I wonder if you chose this as the second question in your betting pool. If you could talk about how profound it would be and what it would mean to restore human spaceflight from U.S. soil. It seems like we're at a real turning point, and it's just that closer, what that would mean from both SpaceX perspective and from NASA's. Thank you.
I'll let you go, Elon.
Oh, okay. I was going to let you. Well, I think it's really quite profound. I think the United States is very much a nation of explorers, a distillation of the human spirit of exploration, and it's obviously something that appeals to people with who have an adventurous. Anyone who has an adventurous bone in their body is going to be very excited about this, and I think it will help reinvigorate interest in space. It's remarkable to think that the last time that a crewed launch vehicle departed from the United States was, I believe, 2011 or thereabouts. So it's been almost a decade, which is remarkable. And so I think it'll be really profound to have that. It's kind of to be back in the saddle again and to be launching frequently with an astronaut crew. I think it's something that matters to all Americans and to people worldwide.
And I would say certainly we are 100%. We are a nation of explorers. We're also a nation that leads, and this, of course, represents us returning American astronauts to space on American rockets from American soil. So this is a great opportunity for us to once again lead. And this time when we lead, we're doing it differently than we've ever done it before. NASA is going to be a customer. We're going to be one customer of many customers, and we want Elon to have lots of customers. But we also want to have numerous providers. We need dissimilar redundancy. You guys have heard me say this. I'm going to keep saying it. We've had days in this country where we lost a space shuttle and our space program was down for a period of years at a time. We need to make sure that we have redundancy in a way that doesn't happen again. And of course, if we look at what we've done with commercial resupply to the International Space Station, there's a perfect example of how sometimes when there is a setback, we can continue to move forward because we have other solution sets to accomplish the objectives. So all of this is important for a very specific reason. We're on the cusp of commercializing low Earth orbit. I want to see large amounts of capital flowing into activities that include humans in space. And those activities could be industrialized biomedicine, it could be advanced materials, and it could be people that want to go to space for tourism purposes. But I will tell you this, there is a future where space is commercialized. And I also want to be clear that NASA will always have a presence in low Earth orbit. We are not, there's a lot left to learn. We are only on the beginning of what we're going to learn. So what does that mean? That means NASA is going to be a customer. We just want to make sure there are customers that are not just NASA. That drives down our costs, it increases our access, and it's not just for us, but for the entire world and for the private sector as well.
Next question. Lauren, second row.
Hi, Lauren Gresh with The Verge. The explosion that happened today with the Falcon 9 looked really cool, but I'm curious to know what would happen if an explosion like that occurred while the Crew Dragon was still attached. The Crew Dragon was quite a bit away when it occurred, but is there any concern about that happening for the crew's safety, and how quickly does that capsule move away in those first couple of seconds?
Sure. In principle, the system is designed to withstand a sort of a first stage booster explosion that is, or upstage explosion that is that happens when basically even before the escape event. So it's intended to be very robust in principle. And the way you think of the rocket booster is it's less of an explosion than it is fire. So it's a fireball, but it's much more fireball than it is an overpressure event like an explosion. Since the spacecraft has a very powerful base heat shield and even leeward side heat shield, it should be really not significantly affected by a fireball. So it could quite literally, like something out of Star Wars, fly right out of the fireball. So that's obviously we want to avoid doing that, but but it is really meant to be something that can fly out of the fireball. There's maybe a few points that are worth mentioning. That how is Dragon better than some what was done, say, during the Apollo era? The fact that the launch abort system is integrated with the spacecraft, with the Super Draco thrusters in the sidewall, means that you have launch abort capability all the way to orbit. And whereas previously with the launch escape tower, that because it's so heavy, that is discarded often just 20 or 30% of the time into flight. So shortly, not long after liftoff, the typically launch escape tower, which is sort of the historical architecture, would be discarded. So you would lose the ability to abort after that point. Whereas Dragon has abort capability all the way to orbit. And then if you have a state change, anything that's a significant state change post liftoff is something to be concerned about. And not having to eject the launch escape tower, I think, is also an improvement in safety. So I think those two are significant steps in the right direction. There's also an improved ability for reusability. Since you're not throwing away the launch escape tower, you retain the Super Draco thrusters. That you can now reuse the launch escape system with every flight, because it should hopefully be very rare that the escape thrusters are used. So that I think those three points are a meaningful improvement over designs in the past. And then one of the things obviously this requires ongoing discussions with NASA, but I think it would be quite cool to use the boats that we are using to catch the fairing, once that is really well established, to catch Dragon as it's coming in from orbit, and then that would alleviate some of the constraints around a water landing. But that's obviously there's some time before making that happen, and we obviously need to recover fairings reliably before we would consider trying to catch the Dragon. But I think that would be also an improvement as opposed to landing in the water.
And if I can just add one thing to what Elon's saying, one of the most important things is that we're monitoring the vehicle, the launch vehicle, to make sure that you're recognizing when the launch vehicle is having a problem so that the abort system's working, right? So we've spent a lot of time together talking about, how does the spacecraft monitor the launch vehicle and then make sure that it's going to abort before it starts getting into those situations too, right? So all the things Elon's kind of like icing on the cake and additional. The spacecraft's robust. It can handle, these kinds of situations, but more importantly, we're getting the crew away before the launch vehicle is in a position where you're having to expose the crew to the fireball, right?
So and everything he said is absolutely accurate. There are huge advantages to integrating the launch abort system into the spacecraft itself, and those advantages are we can abort all the way out to almost space. The downside is it's engineeringly it's a very difficult thing to achieve, and of course we learned that back in April when we had some oxidizer go into the pressurant system and resulted in a catastrophic loss. But that's why we do these things. That's why we test, and because of the way we're acquiring this, we have very innovative partners that are doing things that have never been done before with a purpose. The purpose is to ultimately save lives, drive down costs, and increase access to space. So all of these things are working. It is absolutely true that we will have setbacks as we learn these things, but it is also true that we are going to be better off for it. And of course, what Kathy said is absolutely true as well. This spacecraft knows precisely where it is in space. Latitude, when I say space, I don't mean outer space, I just mean in space in general. Latitude, longitude, altitude, yaw, pitch, roll, trajectory, velocity. It constantly knows where it's supposed to be, and it knows what's happening to it. And so it can make a determination early, before the explosion were to happen, to execute the launch abort capability. So I think we're where we need to be, but it hasn't been without pain. And going forward, we're going to be better for it.
Great. Joey, second row. Yeah.
Question for Jim and Elon. Or first, Elon, will you be able to recover any of the Falcon 9 or its second stage? How badly, damaged was it when it hit the ocean? And have you? There was a pretty tall plume of smoke, so I don't know. And for future Crew Dragon missions, have you signed up any private astronaut missions yet? Does this test kind of push forward any agreements with that? And for Bridenstine, similarly, have you signed up any international partners? And what does this mission mean for that? Thanks.
Well, there's definitely not any big pieces of the rocket left. If you saw something, there was a sort of an object that was sort of falling. We think that's most likely the thrust structure of the first stage propulsion section, which is extra robust and has the engines in it. But that is going to hit the water hard and then be somewhere down at the bottom of the ocean. So we're not expecting to recover anything. In general, we would not expect to recover anything in a launch board scenario. So that it seems quite unlikely. Yeah. I think we don't have any anything to announce in that regard at this time.
I think we need more customers, is what I think.
Yeah.
But on the international front, you should know this. We have no shortage of partners that are wanting to have access to space, and this is going to give not just us, but them additional access to space. We don't have any agreements at this point to ride on these vehicles, although we're going to have, the International Space Station, we've got 15 nations that operate it. We've had astronauts from 19 different nations, and we anticipate those partnerships all to go forward. And of course, they're going to be very excited about riding on a Falcon rocket and in a Crew Dragon. Yep.
Great. We're going to take some questions from the reporters that are on the line. The first one is from Jackie Waddles, CNN. Jackie?
Hey, folks. Thanks so much for doing this. So I wanted to check in about the parachutes. I know it's early, but were you pleased with how the Mark III parachutes performed today? And then with whatever testing that you still have ahead for the parachutes, what are you still hoping to determine?
Kathy, why don't you take it?
So today was the second system level test, what we're viewing as a second system level test of the upgraded, what we call our Mark III chute design. SpaceX has been doing a tremendous amount of testing over this last 6 months. Really perfected the design, did a system level test in December, did another system level test, obviously today in a pretty stressing environment, and then we're working together to get a new set of flight chutes and do 2 more system level tests prior to our next crewed flight test. Working through that with SpaceX and looking forward to further learning and hopefully, smooth parachute functioning on the next 2 system level tests. But we're very, very happy. If you saw it today, flawless execution of both the drogues and the mains, and both of those were the new system.
And I would say from NASA's perspective, we are so grateful to SpaceX for stepping up to the plate in a major way to move forward with the Mark III parachutes. There was a time we looked at the safety factor from a Mark II to Mark III. Mark II was good. Mark III was way better. Elon and I had a conversation. I said, look, if we want to move forward quickly, let's go with the Mark III, and let's get as much testing as we can possibly get done between now and the day we launch Crew. And they move forward very quickly. I don't know how many tests you've done at this point, but it's a lot with single chutes. And now we're up to the point where we're doing full system level tests with all 4 chutes. And so far they're looking good. So we're grateful to the SpaceX team. I also want to say thank you to the Airborne team. I've had a couple of conversations with the CEO of Airborne, told him what a high priority this is for our nation. And they've been working overtime to make sure these parachutes are developed and packed, and we're grateful for their support as well.
Yeah, I'd also like to say thanks for the Abort team. They've been essential in this.
This is an unprecedented amount of parachute testing, I think, that we've ever seen from a NASA perspective. So really great partnership across the NASA, SpaceX, and Airborne team.